Ladies and gentlemen, as I've been doing this research into trying to find out and test for a true inquiry into science about climate and weather, it occurred to me after doing several specials that a clear frame of reference needs to be introduced to the general public about what carbon is and what it isn't. And that since the entire new industrial complex, the seed of it is based on carbon dioxide, or CO2, I really think it's imperative that we talk to an expert who can translate what CO2 is and isn't. Ladies and gentlemen, I'd like you to welcome Sherwood Idso, who is assumed the presidency of the Center for the Study of Carbon Dioxide and Global Change on October 4, 2001. Prior to that, he was a research physicist with the U.S. Department of Agriculture's Agricultural Research Service at the U.S. Water Conservation Laboratory in Phoenix, Arizona, where he worked till 1967. He's been closely associated with Arizona State University over most of this period, serving as an adjunct professor in the Department of Geology, Geography, and Botany, and also microbiology. He has a Bachelor of Physics, a Master of Science, a Doctor of Philosophy degree, all from the University of Minnesota. He has co-authored over 500 scientific publications, including the books Carbon Dioxide, Friend or Foe in 1982, and Carbon Dioxide and Global Change, Earth in Transition. He served on the editorial board of the International Journal Agricultural and Forest Meteorology from 1973 to 1993, and since 1993 has served on the editorial board of Environmental and Environmental Botany. Over the course of Sherwood's career, he's been invited reviewer of manuscripts for 56 different scientific journals and 17 different funding agencies, representing an unusually large array of disciplines. As a result of his early work in the field of remote sensing, Dr. Idso was honored with an Arthur S. Fleming Award given in recognition of his innovative research into fundamental aspects of agricultural climatological interrelationships, affecting food production, and the identification of achievable research goals whose attainment could significantly aid in assessment and improvement of world food supplies. This citation continues to express the spirit that animates his current research into the biospheric consequences of the ongoing rise in the air's CO2 content. If there were ever a time where the average person needed to have clear understanding into the truth of CO2 science, it's now, and it's with Sherwood Idso. Ladies and gentlemen, give a warm welcome to Sherwood Idso. It's rainmaking time. Welcome to the show.
Hi.
I really want to thank you for being here. I realize that this is, for some reason, very controversial, but I know that there are some basic frames of reference that you're going to be able to illuminate today that clarify and distill the science for what it is, and the over 30 years of work you've had focused on CO2. Share with us what your take is and how to introduce CO2 to the public.
Well, I guess I'd begin by saying that we are often described as carbon-based life forms because we get what comprises our body from the foods we eat, and those foods, be they plant or animal, originate with plants through the process of photosynthesis, whereby carbon dioxide and water vapor are combined together to produce carbohydrates and various other types of substances that ultimately make their way through the food chain and into our bodies. So carbon is the basis of life on Earth, and photosynthesis is the process that drives it all. And carbon dioxide is what is the raw material that is used by photosynthesis to produce everything else that comes further on down the line. And there have been literally thousands upon thousands of experiments conducted in the real world, both in the laboratory and in the field, that indicate that if you enrich the air with carbon dioxide, as its concentration rises, the photosynthetic response of plants is positive. That is, they grow larger and faster, and they produce more biomass. And this means there is more of the various crops produced that sustain both us and animal life And at the same time, as they are producing more biomass under higher CO2 concentrations in the air, they reduce the small pores in their leaves called stomates. They reduce those openings, so it's a little bit more difficult for water to escape from the plant and be evaporated into the air. So they produce more biomass while using less water, and therefore their water use efficiency rises dramatically. And this is important because water is becoming a very scarce resource on the planet. It has been calculated, for example, that just a mere 40 years from now, even assuming various types of advancements in agricultural technology, that if we are going to sustain the human population of the planet, we are going to need all of the remaining freshwater resources on the surface of the earth to grow the crops that we will need to support humanity at that time. And we will also have to take a large amount of land away from what one could call wild nature in order to do this too. And this means that we are going to be driving innumerable species of both plants and animals to extinction as we take away their habitat. And unless the CO2 concentration of the air is allowed to rise according to its ongoing trajectory, due to the emissions of CO2 to the air by the burning of fossil fuels such as coal, gas, and oil, unless this continues to happen, even with projected advancements in technology, we are going to come up short in terms of food production, and we will have to usurp this extra land and water. And that's what is going to really hurt the rest of the biosphere. Now, it's kind of interesting that this is just the opposite of what you hear from the other side.
Right, and as I was saying to you, as we first spoke, I grew up thinking that carbon dioxide is a polluting phenomenon. So I've been scared of it my whole life.
Yeah, in fact, I think it was just today, or I'm not sure if it happened today or is about to happen, but the EPA is, the Environmental Protection Agency, is classifying it as a pollutant. And this is just ridiculous. It's just the opposite of a pollutant. It does all of these good things for the planet and the life upon it. It is the basis of life on Earth. And here they characterize it as the most evil substance that you can have, creating the greatest catastrophe that has ever faced mankind, the planet, etc.
You call it the breath of life. Why?
Well, for one thing, we actually do breathe it in and breathe it out. We breathe it in at a small concentration, and we breathe it out at a much larger concentration. And you can actually, in fact, I have done experiments of this nature where I have used my breath to enrich the concentration of CO2 in small enclosed biospheres, and I have been able to boost the growth of what I looked at particularly was small sour orange tree seedlings, enhance their growth dramatically by just breathing extra carbon dioxide into the air in which they grow.
Ladies and gentlemen, we are in the process of talking to Sherwood Idso at CO2science.org. Tell us about the organization.
Well, we're just a real small organization right now, composed of myself and two of my sons. They started it, one of my sons started it, I think about 12 years ago, I think it was. And each week we review the scientific literature, looking for studies that pertain to both the biological benefits of carbon dioxide enrichment of the air and the more controversial subject of what the rise in CO2 content may or may not do in terms of the climate of the Earth. And each week we review about 5 different scientific journal articles that touch on these topics, and we've been doing this every week since it began. And we now have a subject index on the site where you can look up any particular subject you're interested in, or you can also search by a keyword and find what you're interested in. And we just keep doing this because there is so much scientific work that's being done that shows the wrong-headedness of this other side, the climate alarmist side. We find that most of the climatic catastrophes that they are predicting are going to occur with global warming are not getting any worse as the Earth indeed has warmed over the last century or so.
Hasn't it recently cooled?
About the last 10 years or so, there has been a very, very slight cooling of the planet. Mm-hmm. And, of course, the models all suggest that it should be rising. It should be continuing to warm. But the Earth is a very complex place. There are many processes that determine the ultimate change in temperature due to a change in the CO2 content of the atmosphere. There is a propensity to cause the temperature to rise, but there are many things that happen consequently and in response to this. Some give positive the warming a bit.
Can you repeat that? Can you repeat that? A call came in and I missed you. Some give what?
Some give a positive feedback, and some of these other things that occur give negative feedback. So there are some things that would tend to enhance the CO2 propensity for warming, and others that would tend to reduce it. And all of the evidence from the real world suggests that these negative feedbacks predominate, so that there is not any real compelling reason to believe that the Earth will necessarily warm at all due to an increase in the air's CO2 content because of these negative feedbacks that can occur. I have done a lot of looking at what I call natural experiments, where you look at something that occurs in the real world, like a change in radiative forcing of the atmosphere, and you look at how the temperature changes. And I think I've had about 10 different experiments of this nature, maybe it was 8, and they all indicate that if you had a 300 to 600 part per million doubling of the air's CO2 content, you would probably only increase the temperature of the planet by about 0.4 of a degree centigrade, whereas climate alarmists give you a figure that's about 10 times that great. Another interesting thing about it is that, they're always worried about it getting so warm. We've just come out of a period of time called the Little Ice Age, which lasted right up until about the beginning of the 20th century. And this was the coldest period of the current interglacial. It's the coldest period of the current interglacial, and the current interglacial has been cooler than the prior several interglacials. So we're at an extremely low temperature, relatively speaking, to what the Earth has been for just a tremendously long time, and it's not unusual at all for it to be warming at this time just due to recovering from that extremely cold period.
Why is it that there are any scientists in the world who are aligning with a false scenario, a false story about carbon? Why does even one scientist willing to say that carbon is the cause? How can they face themselves?
Well, I think like anything, there's usually a spectrum of people with a spectrum of views, even in different camps, as you might say. Like, we're often referred to as the climate skeptics by their side, and we often term them the climate alarmists. But I think that within each side, you also have a spectrum of thought. And I am sure that there are some that honestly believe that CO2 is going to do what they're saying it's going to do.
But how can they believe it if science is about proving things? How can they call upon belief rather than the studies and say that?
Well, I don't know. That'd be a good question to ask them. Sometimes I wonder myself. But their belief, let us say, is based pretty much on these models of the atmosphere which they create. And I don't know. I guess it's like if you have a child and you kind of want to believe in your child, that's kind of like maybe where they're coming from. But I guess I really shouldn't put words in their mouth. But I tend to disbelieve their results because they are purely theoretical, and they could easily be wrong. Because think about it. In order to be correct, they have to be correctly characterizing in their mathematical models all processes in the natural world that may have an impact on the climate. And I tell you, there are a lot of processes that go on in the real world that are probably not included in those models. Some of them involve biological phenomena. There are many.
Can you name a couple?
Well, plants give off a lot of types of things into the air, various different types of gases. Some of these can be converted into particles. Some of these particles can act as cloud condensation nuclei. They can cause more and brighter clouds to be created, which would reflect more of the incoming solar radiation, which would tend to cool the planet. This happens with life forms on land and life in the ocean, in fact. And these kinds of feedback are very complex, and the models do not include all of these things. And then there could well be things that we don't even know about that would obviously not be included in the models. I think it's kind of, I don't know what's the word, unrealistic to think that the models include everything of significance to the climate. I'm sure there are things we don't know about that aren't in there, and there are other things that we do know about that are not in there too. And so, I look at how the natural world responds to various perturbations that could cause its temperature to change, and I get a result that's only about a tenth as large as what the models get. And then I also look, another kind of thing that can be looked at is if you go back in time about 1,000 years, you find that there was a period called the medieval warm period, because it occurred in medieval times, and it was warm. It was at least as warm, if not warmer, than what it is right now on the Earth. One of the things we do on our website, we scan the scientific literature, and there is so much work that is done just in this field alone that we can report the results of a different scientific study every single week dealing with the temperature of the medieval warm period. And we do this on our website, and we've been doing it now for, I don't know, maybe a couple of years or so, every single week. And we look at these paleo temperature studies, and those that are good enough to get actual temperatures out of them, the vast bulk of them show that it was warmer back then than it is now, when there was way less CO2 in the air than there is now, indicating that something other than CO2 caused the planet to be as warm or warmer than it is now.
What do you think of radiation? There's several types of radiation that aren't even on the table in the climate dialogue throughout the world. Number 1, microwave radiation. Number 2, solar radiation that gets into Earth's atmosphere. And number 3, which is a completely separate thing, but there are a lot of planes spraying aerosol into our upper atmosphere all over the world that are spotted. Not one of these things I'm mentioning to you has ever been on the equation or on the table in the talk about climate and climate change, climate weather, or climate itself.
Well, actually, a lot of those things are. They deal with solar radiation. They deal with long-wave thermal radiation. They'll look at various other parts of the spectrum, too, and they do deal with a lot of that.
Who's they?
The climate modelers.
Oh, but I've never heard it in the dialogue as impacting impacting climate. In other words, as even a factor that could impact climate. I've never heard it ever publicly spoken about, that radiation or solar rays or anything like that would have a potential serious impact on our climate system and weather in particular. I've never heard it. I'm not saying...
Well, they do deal with these various types of radiation.
Right. I'm talking about the IPCC.
They would be dealing with it too. But normally, let's say like solar radiation.
Right.
They feel that the variability of solar radiation is not large enough to be able to explain the amount of warming that's happening or that has happened over the current century or so. So this is a very complex subject that is argued about extensively, between the two sides. There does not seem to be enough change in the solar radiation itself to explain the changes in temperature that occur, but there's some thought that there are other things involved in it, that there is cosmic rays that are blown away from the Earth by the solar wind and so forth, and that the solar wind is a means of amplifying some of the other changes that could occur on the sun. It's an extremely complex subject that they've been arguing about for years, and it has not been resolved to anybody's satisfaction yet. But it could go one way or the other.
So what happens if laws are passed internationally that there's going to be this attention to our carbon footprint? Now, since we're carbon-based life forms, and most plants and animals need carbon for life, including us, what is the translation of this new law or this new monitoring apparatus and this new focus that's away from carbon dioxide? What's going to happen?
Well, it depends upon how successful they are. I think it's going to be incredibly difficult for them to ever make much of a dent in the amount of anthropogenic CO2 emissions given off into the atmosphere. Countries in Europe that talk about it and so forth, they have not been that successful in reducing CO2 emissions. The CO2 content of the air continues to rise and rise. Places like China and India coming online, becoming more energy intensive, keep the CO2 concentrations rising. It's really going to be impossible to make any significant impact on it. And it is just going to be a tremendous drain of monetary means that could be used for other more beneficial things to help raise the standard of living in other countries much more rapidly, and then actually perhaps learn how to reduce CO2 emissions if they are so concerned about it by, making the transition less painful. But on the other hand, I truly believe that the CO2 content of the air should be allowed to rise. In other words, I think it should be allowed to take its natural course because of the benefit that will provide to humanity in terms of being able to produce more crops to feed the greater population we'll have in the future, and to enable us to not have to take a whole lot of freshwater resources and land away from the rest of the biosphere. I think that just letting nature take its course, and by including nature, I talk about also, human civilization and so forth. We are always progressing, and there are probably things that we will do to have different sources of energy in the future, and but I think that they should just come naturally. You know what I mean? Rather than trying to just change the way the world operates so rapidly when we're not prepared, to really do it.
There's a lot of new industrial applications for measuring CO2 in a person's home that are not only being made, but some are already done and ready to roll out to the public. Are you aware of that?
Probably not the ones you're speaking of. I know that there is instrumentation for doing that. In fact, I've measured the CO2 concentrations in my house over a period of a couple of years, a few years back. And it's interesting. You get very high concentrations inside of a house just from the people breathing in the house, and you can get several hundred parts per million more CO2 inside than you have outside. And of course, in an urban area, the CO2 that's emitted from various forms of transportation usually boosts the CO2 content of the air also. It sort of has a diurnal variation. During the evening when there is an inversion that occurs, the CO2 builds up in the lower level of the atmosphere, and you have sort of a CO2 dome that forms over metropolitan areas. But then in the daytime, when the sun comes up and starts heating the surface and gets convection going and mixing to higher levels, that kind of sucks it up higher into the atmosphere, and then the concentrations fall again. But CO2 is extremely variable in an urban environment and in almost any smaller place, too, when you go between inside and outside of your home. It's a lot higher inside your home than outside.
Do you think that people can actually control how much CO2 is in their home?
The only way you would control that would be as to how much ventilation you have between indoors and outdoors. And in the summertime, say you open your windows or something and you get a little air moving through it, it drops it way down. But the fact that it's high in your home doesn't hurt anybody. You know, you have to get extremely high concentrations before it becomes harmful to people.
Well, give me an example of that. In other words, what is considered, what's the frame of reference for what's okay, what's good for you, and what's harmful?
You know, I would have to look up on my own website to see what the answer to that is. But I think you have to have several thousand parts per million before it begins to have a problem for human life, or probably any life. But I can't remember exactly the exact numbers. But it's nothing like you're going to get in the home. Normally it'll just be a few hundred parts per million higher than normal.
Wow.
And if you go to some place like an auditorium or a theater, and then where there's more people, probably get higher yet, maybe a couple thousand parts per million even.
How many people are involved right now and are going to your site, co2science.org, to really learn the science? How popular is it, and how's it going?
You know, I can't. Several years ago, we used to keep track of that, and I wish I could remember. I can't even remember what it was back then, and I don't know what it is now. Couldn't tell you.
Okay. I have a question about the whole thing about the sea rising. I noticed you have an article here called The Past Half Century of Sea Level Rise.
Uh-huh.
That was updated back in 2008, November. But what is the whole issue about the sea level rising?
Well, people are concerned that if the planet warms a significant amount, that you might start melting the Greenland and Antarctic ice caps, and if you were to melt all of them, you'd have a tremendous increase in sea level. But there's so much ice there, and it's so cold in these areas that it's a very, very slow process. And this is what the debate comes down to relative to that. Just how fast is this process? And a lot of the models suggest that it could become fairly rapid. But most of the real-world data makes that a questionable assumption. We do have some melting that's been going on in the Arctic. It's been warming there, and sea ice has been decreasing. But if you go down to the Antarctic, sea ice is increasing. And there has been no significant large increase in the rate of rise of the sea level. It could well slow down somewhat too. It can vary now and then, depending on various things, but we just don't see anything happening very rapidly. And especially, if it's not going to warm. I mean, it hasn't warmed now for the last 10 years or so, and
I don't think the public knows that at all.
A lot of
Sherwood,
people think they can, but
I don't think the public knows that it hasn't warmed in the last 10 years.
That's possible that they don't know that, but if you go and look at the data, I mean, you can go onto our website and you can access the databases, and you can look at what the globe has done over the last, I don't know, maybe years or so, and you can see there over the last...
Oh, the U.S. Historical Climatology Network?
That's one place. That just deals with the U.S. If you're looking at the website, let me get back to my home page.
So I'm looking right now. I'm trying to...
Right up at the top there it says data.
Right.
You drop down to the bottom where it says world temperatures, and let's say you go over to HAD CRUT 3, let's say.
Okay.
And if you just click on it where it says calculate trend right at the bottom right now,
yes,
it will show you from about 1880 up to looks like 2006 is where our database ends right now. And
wow.
Just wait a second, and a graph should come up.
Right, I see
that.
it.
Yeah, it's popped up there for me. Well, this doesn't show you quite up to the present, but you can see a peak there in about 1998, I believe it is, and then it drops down, and then it comes up again. But if you could see out to 2009, you would see that it is decreased very slowly across that point. In other words, there's probably been no warming for about 12 years, and it has a slight tendency to be cooling at the present time.
That's remarkable.
Uh-huh.
What is NOAA?
National Oceanic and Atmospheric Administration.
What do they do?
Well, they do a lot of things.
Did I ask a bad question?
Well, it's like
just
a
came
real
to mind.
Question. It's hard to give a
well, I mean, who do people think they are? Let's first of all find out who. When someone thinks of NOAA, what do they think what are they thinking about that they are?
Well, they study things related to the ocean and atmosphere. National Oceanic and Atmospheric Administration. They have databases of all sorts containing the things relative to the ocean and the atmosphere, and a lot of scientists working for them, and a lot of administrators, and I don't know what else to tell you.
In your work, do you ever deal with them related to CO2, or do you ever have reason to talk with them, or do scientists cross-pollinate information with them related to CO2?
Oh, I'm sure some do. We don't have anything to do with them. We probably review papers now and then that are written by some NOAA scientists, but we don't have anything to do with them directly.
Okay. So it's like a whole other focus.
Well, a lot of their focus is on the things that we're focusing on, too. But like I say, we would probably be reviewing some of the papers of some of the scientists that work for that organization.
Got it. So what else do we need to know about carbon that you haven't said?
Well, there's probably tons and tons and tons of things because, if you go to our subject index, you get another alphabet, and then you get all of these different topics. I mean, we probably have several hundred topics.
Oh, my God, you have a lot. I'm there right now. I'm at the subject index.
Topics that we file, all of these
all related to carbon.
Yeah, articles that we write about. Yeah, I suppose you can go to carbon. You can find a lot of things under that. I'm just going to go there myself.
This is a really packed site. How long did you spend on this site? This is pretty big.
I think that we started my son started about 12 years ago, and then I came in the latter part of 2001, and we put out a new issue of this website every single week. And if you go to our home page, you see this home page will change every week. Now my computer must be stuck. There I go. We just happen to have an extra thing at the top of this page called Copenhagen Climate Concerns. I think we got about 52 different short videos underneath that different scientists have contributed talking about the subject. Oh, and then we tell people to donate to our center. We need money. Then we have an editorial every week about something, and I see we have an extra editorial this week too. Then we have this medieval warm period project where we each week publish the results of another paleoclimate study that identifies the medieval warm period, and many of them tell its warmth compared to the current time. Then we have a subject index summary. We have all these topics, these hundreds of topics, so each week we'll try to summarize the things underneath one of those topics, and that's what appears there. And we have this plant growth data section where each week we upload the results of 4 different peer-reviewed studies that have actually experimented with CO2 enrichment of plants, and we find out, how much they enhance the growth and so forth. Then we come down to journal reviews where we have 5 entries each week. We usually have 2 that deal with either biology or climate, and then 3 that deal with the other one. So each week we have something of a biological nature and something of a climatic nature. And each week this changes, and next week we'll have 5 different journal reviews, and these 5 here, they'll be filed under one of the topics in our subject index.
What about the coral reefs? Can I ask you about that? What is does CO2 have anything to do with coral reefs or the fact that the coral reefs are dying? What is going on?
Well, a lot of coral reefs have had problems for many years because of all of the things that mankind does right in their presence, right close by them, People visit there, they go down and they break off a piece to take home for their saltwater aquarium. You have other boating and so forth that goes on. You have pollution from boats. You have pollution that comes from rivers that flow into them. You have runoff of pesticides and chemicals from agricultural lands. There's just a whole host of ways in which mankind has been negatively impacting coral reefs. But what the climate alarmists usually talk about is the rising temperatures, which they say will lead to coral bleaching. What that is, when the temperature of the water gets too hot sometimes, the corals expel the algae that live, the symbiotic algae that live within them and that provide food for them. And when they expel those algae that are providing the food, they lose the color that the algae might have had, and they also, if the algae don't come back and repopulate them, the corals die. And so this is a problem that sometimes can happen when the water gets too hot. We also find, however, that it sometimes can happen when the water gets too cool. The climate alarmists usually are talking about, well, it's going to get so warm that these corals are ultimately going to die. But the interesting thing about it is that both the coral and the symbiotic algae, they can evolve. They can evolve fairly rapidly, in fact, and they can evolve to tolerate higher temperatures, and we see evidence for that going on in the real world. Another thing that they say about corals is that the carbon dioxide rise in the atmosphere will lead to an acidification of the ocean water.
I was going to ask you about that.
Yeah, and it can cause this to occur to a certain degree, but there are a lot of experiments that have been done with corals that indicate that oftentimes the symbiotic algae that live within them, they're benefited by this increase in CO2, and so the corals do even better. And in fact, we've got a little book that we put together where we have actually looked at what's happened in the real world in terms of coral growth rates in various parts of the world over decades and centuries. And as it has warmed and as the CO2 content of the air has increased, we generally find increases in the growth of coral. So it could well be that they may do better in a warmer and a CO2-enriched world. There's a lot of real-world biological evidence that suggests that this may be the case.
Could acidification also come from volcanism? Because we're just finding out that there's many more hundreds and thousands of volcanoes in the water that we didn't even know existed?
Yeah, it could come from that,
Because
in fact, there's some places where CO2 just bubbles out of the ocean bed. And I was just reading something today, in fact, that showed that there were some, I can't remember what it was living down there by these areas where the CO2 was bubbling out, but they were thriving.
So nobody has to be afraid of carbon dioxide?
I don't think so. There's been a couple instances where there has been something bad happen. Like I think there was a lake somewhere over in Africa here, I don't know, quite a few years ago that burped, so to speak, and released just a whole lot of pure carbon dioxide that at night, being heavier than air, it spread out across the land and killed animals and some people that were living in that area where that happened. But that's an extremely rare kind of circumstance. I mean, what normally goes on, there's nothing that you really have to worry about with respect to CO2. I mean, you're never going to run into anything, any place that it is too high unless you're in a submarine that all of a sudden malfunctions and you cannot raise from the bottom of the sea.
Is it true that CO2 is heavier than air?
It is, but I mean, as soon as it gets released into the air, the motions of the air mix it, and so it mixes, you know. If everything was absolutely still, that would be a different case, but it's never absolutely still, and it's always mixing and being diluted up into the air.
Wow. Is there anything else you wanted to add to communicating to the general population about CO2 science?
Well, only that, you know, we really need to, whatever we do, it should be based on, you know, sound science. It should be based on things that we're pretty confident about. With respect to what's going on right now, you know, over in Copenhagen, people are trying to change the way the whole world operates, so to speak. And it's pretty much based on theoretical models that really have not been proven to be correct or accurate, or however you want to describe it, never can be truly validated. Now, on the other side, we have the real-world evidence of actual experiments that have been done, which show that carbon dioxide enhances plant growth while it reduces the amount of water that is used to produce a given unit of biomass, so that we know it's beneficial to plant life, which then means it's beneficial to animal life, which means it's beneficial to humans because we need those plants to sustain ourselves. And on the climate side, there's also a lot of real-world evidence. We can look at what has happened to various things, like, let's say, hurricanes, let's say droughts and floods, as the planet has warmed over the last 100 or so years. And, you know, the climate alarmists always say that with this warming, we're going to have all these catastrophic droughts, catastrophic floods, hurricanes, and so forth. But if you go to our website, look up floods and droughts and hurricanes, and you can see just dozens and dozens of papers that have been studying this subject all around the earth, and you find that this is not true. And so there's a lot of things that the climate alarmists are predicting that we know from real-world observations are not correct. And also, we know what the climate has been like over a long period of time. We know it was as warm or warmer 1,000 years ago during the medieval warm period. We know it was as warm or warmer another 1,000 years before that during the Roman warm period, and so forth. And so the bulk of evidence is against these people in Copenhagen. And even if it wasn't, you still have the thing that it's merely a theoretical model that they're using. And, you know, do you want to gamble that they've got everything in that model or those models that is of significance to the climate of the planet without knowing anything else other than how complex the world really is? I would not want to bet on it. So, from that point of view, and all of the real-world evidence that we have that is contrary, you know, I conclude that there's nothing to worry about the CO2 content of the air rising, and that, in fact, it is probably, most likely, a beneficial thing to happen because of what it will do to helping to provide food for the planet.
And with the breath of life.
Well, I like to call it carbon dioxide.
Carbon dioxide.
Yep.
Carbon dioxide being the breath of life. How do we communicate this to the rest of the world?
I don't know. We've been trying to do it like my sons have for 12 years, and I guess I was even doing it before that because I started studying this while I still worked for the federal government and did a lot of experiments. In fact, I was sort of a co-principal investigator on the world's longest CO2 enrichment study that had ever been conducted. I guess I could tell you about it.
Please do.
We planted some small sour orange tree seedlings in the ground out at our laboratory, the U.S. Water Conservation Laboratory, and we had 8 of them, and we enclosed them in pairs with clear plastic wall chambers that were open at the top. and then through perforated plastic tubes that lay across the surface of the ground inside of these chambers, we pumped either normal air or air that had an extra 300 parts per million through these chambers 24 hours a day, every day of the year for, 17 years. And these trees grew and grew and grew. They grew to be huge. And in that little video on our website that I think I told you about, you can see these trees in one of the pictures. I'm standing in front of them, and you can see how huge they are compared to my body there. But the trees that had, I guess they had about 75% more CO2 in them than the ones that were in normal air. They produced about, can't remember exactly, about 60% more biomass, more trunk and branch volume, more root volume.
That's huge.
And they produced even a greater percentage enhancement of fruit. I can't remember what it was, 80% or 90%, something like that. And that fruit actually had anywhere from about a 5 to 15% greater concentration of vitamin C within it even. So, I've done so much of this work on so many different kinds of plants, and hundreds of other scientists have also. There's just no question about it that CO2 is the breath of life. It helps everything grow better.
I really want to thank you for taking your time today to communicate to the public the science of CO2.
That's what we try to do via our website, so I guess it's hard to turn you down.
Tell them where to go for your website.
Go to CO2science.org. That's CO with the numeral 2, altogether, CO2science.org.
And are there books anybody can buy or DVDs anybody can purchase?
Yeah, there are. We have some DVDs listed along the left-hand sidebar of the site. And I guess on the top there's a place that says videos also, and I think that you can maybe buy them there. Anyway, I think on the sidebar you could click on those. Those are for sale. And we also have a lot of short DVDs that we put on. This last group is called Copenhagen Concerns. Then we have a group called The Scientists Speak, another one called CO2 Truth Alerts, and then we have these featured DVDs. Those are the ones that can be bought, those featured DVDs. But there's many video clips here on the website that people can look at.
Sherwood Idso, thank you so much for being here with It's Rainmaking Time. And as people listen in, they'll probably have questions. I'd like the opportunity to call you back and have you on as questions come in on the blog.
Okay.
And thank you so much.